You may hear the word signed a lot when I talk about the numeric types. Sign means that the types have a sign, being minus or plus. This sign allows the type to represent both positive and negative values. Usually, numeric types without a U at the beginning are signed. U stands for unsigned, meaning the values can only be positive. All numeric base types are defined with a struct and are value types. A 16-bit type means the type can be represented using only 16 bits, or 2 bytes of space. Let's open up the calculator and enter the highest number in binary using 16 bits. Okay, so I'm going to go over to the programmer view, and I'm going to go into the binary thing here, and I'm going to type in the maximum value of 16 bits, which will be in 1. And we're going to convert it to decimal, and that would be the maximum amount of whole numbers we can represent using 16 bits. It's very obvious when you're working with the short, because you only can represent 65,500 values. It might be a bit different with a floating point number, but that's how it is for the integers. Some space weenies will use the smaller types and attempt to save space. In most cases, this is unnecessary because physical memory has been overly cheap and abundant for computers for a while, as well as you will have to do a lot more casting when working with the .NET framework, as the framework tends to use the common numeric types over the others. All numeric base types will have a static property to get the maximum and minimum values for the type. The first declared variable is of type int. Int is short for integer. It is the most commonly used number type in my experience. Integers are 32-bit. They hold signed whole numbers with a total range of just over 4 billion. Uint are very similar, but the 4 billion possible values that it can represent are all positive. This means that you can represent a much higher positive number than the int. Longs are another type of integer. Long integers are 64-bit and can represent very large numbers. I do believe you can represent numbers from -9 quintillion to 9 quintillion. And of course, the unsigned version of this type will represent up to 18.5 quintillion positive integers. Shorts represent integers as well. It can represent a range of just over 65,000 numbers. As you may know, the range will be split into positive and negative numbers. The float is known as a single floating point number. It's a 32-bit type and can represent 7 digits. Precision is typically measured by the digits the type can represent. I can try to assign more than 7 digits, but the precision over 7 will simply be discarded. And when I boot up the app, you'll notice that I only get 7 digits. You can define hard-coded floats by postfixing the number with an F. Double stands for a double precision floating point number and is a 64-bit type. It's a double because it's twice as precise as the float, which is the smallest floating point data type. Floating point means the decimal point can be anywhere in the number. By default, any hard-coded number with a decimal place and has no postfix will be interpreted as a double. You may want to add the letter D to the end to explicitly indicate that it's a double. A decimal is a 128-bit type, and it's virtually twice as precise as the double. It also is a floating point type. You can define hard-coded decimals by postfixing the number with an M. A byte will evidently hold 8 bits of data. The 8 bits can represent whole numbers from 0 to 255. Unlike the other types, the byte is unsigned by default. You can define a signed byte by using the sbyte type. Bytes also don't seem to have a postfix. I believe this is acceptable as all other number types can encompass the highest byte value.